In the last part, we learned about what are patterns, what are AI weights, how does the AI model training works, things like that. In this section, we are going to learn about what is GPT or generative pre-trained. Along with that, Daniel is going to explain what is a transformer and what are tokens and how these tokens work. Enjoy.
Well, let's just take another look at this generative pre-trained. So generative, what does that mean? We've used this term generative. Again, models, large language models that were able to generate content have actually been around longer than GPT-4, but it has been the GPT models from OpenAI, though that certainly popularized the term generative. It means it's able to create new content or predict content um, based on an input. The pre-trained in GPT means that it is pre-trained. You don't need to train it. You just take it as is. In fact, you can't train it. You've got to take it as is. And yes, you can fine tune some of them, but that's a discussion for another day. You They are optimized to be general purpose, and some of these models you can fine tune to behave in certain different ways to do different things. But generally, the generative, they're pre-trained. It's the GPT. An example of that is, I mentioned before, the owl and the pussycat. What's the most likely next word in this sentence or series of words? Went to sea in a beautiful pea green boat. That is, I think, a poem from, I can't remember where, but it was part of um, that is likely to have been seen many times by the training data, that statement, and so therefore the neural weight of this relationship is quite high. Why is the sky blue? The next tokens or next words that are likely to follow this when I enter why is the sky blue is going to be a description of why the sky is blue. And that is because it's likely, or something similar is likely to have been seen before. So again, it's predicting the next likely series or set of tokens from the input. But what's a transformer? So transformer is an architecture. It's a way of describing how the internals of this model works. We don't really need to go into too much detail about that because again, it's not a thing you need to worry about. But what is
Mhm.
really important with a transformer model is it enables something called self-attention. What self-attention means is that the tokens that are generated by the output are then used back in the input, and it helps the model stay on track with what it's actually generating. So if we were to say dog was enjoying its bone, later in the day it buried it for safekeeping. Now we as humans recognize that the dog is not burying its own bone and its own leg or you know um, its own tailbone. It's burying the bone that it was enjoying. We know that. But previous to transformer models, these models weren't good at determining that have that self-attention to know that it was actually referring not to its own skeleton, but to the bone that a dog enjoys. So if we look at how that works, the model is actually able to understand or infer that the term dog, its, and bone are related, and the it um, in the um, in the sentence relates to both either the dog and the blue, it relates to the bone. All of these things are enabled by a transformer architecture. And this is really important because earlier models previous to this, they would get confused and say, well, the dog is trying to bear its own skeleton because that's what I think.
Mhm. Mhm.
So that is really what has been lit up by this GPT model, the generative pre-trained transformer. And this is what really enables these long series of outputs to stay on track, to give you relevant information when you ask a model, hey, I would like you to help me develop a business plan to start a new company that sells bicycles. I would be able to ask a model that and it would give me a good answer because it is able to use this self-attention. And I've previously referred to tokens. This is another important concept. These models don't predict the next word in a series of inputs. They don't predict um, the next letter. They always use tokens. Now, a token is a way of breaking the concept down into a smaller chunks that are not too small, because being a letter would actually mean that the neural net was too sparse. And they if the if we use words, it would be too broad. So what was needed was a smaller chunk that was able to be used to represent the neural network. So you'll often see these models, the input of the model and the output of the model, uh, that is referenced by tokens. So what actually happens when you use a large language model is you write a prompt, which is a piece of text, that is broken down into tokens by the model, fed through the transformer, and then output is generated as tokens. Token by token, you will see come back to your screen and shown on screen saying, the owl went to sea in a pea green boat. You don't need to worry about too much about how that process happens, but you do need to know that it does happen. And therefore, when you are told, you can send 128,000 tokens to this model, which is the limit
Hmm.
of GPT-4 Turbo, or GPT-4o, you have to be aware that that actually represents about about 0.75 words per token. So you can roughly guess how many words that's going to be is somewhere along the lines of 90,000 words for 128,000 tokens. Now, that's a lot, but if you think the entire works of Shakespeare is about 1.2 million tokens. So you can send through to GPT-4 at any given moment about the tenth of the works of um, Shakespeare. Whether you want to do that, I can't
Yeah.
imagine.